Okay, so this session is about standards and ontology standardization. It become on the table usually when we discuss with industrials, with different stakeholders, the problem of standardization, this topic. And usually people say, yeah, we need to standardize ontologies, and others said, we need to ontologize standards. So it's a great topic that we'd like to discuss with our experts. So we have 4 speakers in this session. So we'll go through presentations, short presentations, and then we'll have a panel for discussion. So we have 4 speakers. 3 are in the room. 1 is online. Alexandru Tudor, he's a researcher at Fraunhofer. He's representing the German Institute of Standards, Dean Software. We have Barry Smith from University of Buffalo, Jim Wilson, chair of OAGI, and Johan Kloer from DNV. So I will give the floor for Alexandru to represent their work on the standardization of ontologies in DIN. So Alexandru, please share your screen and you have the floor.
Okay, can you? So I hope everyone can see me. Sorry, I couldn't be in person there. So I'm Alexandru Tudor. I represent Dean Software. So we're a subsidiary of the German Institute of Standards. I was previously at the Fraunhofer Group for Materials in a similar role, and in part of a project, I also moved to DIN. Let's see if I can share my screen. So since we don't have that much time, I'll try to start quite fast. So this is part of our work to combine the latest developments in standardization with ontology development. So as some of you might know, right now standards organization are digitizing, trying to go from publishing paper to publishing data, and to modernize their pipeline to go from paper to PDF, which they've already done, now to XML, which is the next step, and then to machine readable and machine interpretable content in order to provide the necessary data for Industry 5.0 and for the new technical developments in AI. And in order to realize this, there's this smart standards development in the area. Now, smart standards are basically publishing XML and enriching XML instead of paper, and it has different levels. Level 0 are the traditional standards documents. It's basically the paper or text files that we have. Then level 1 PDF already has a series of metadata attached to the standard itself. Then going to level 2, where we are already publishing XML with a lot more information. It's paragraph-centric, where you can actually identify individual paragraphs, have a lot more metadata than in the classic PDF standards. And the roadmap for 2024 is actually going beyond that, having sentence-centric data publishing, where you can identify each sentence, each requirement, provision, recommendation, etc. in the standard, in order to set the groundwork that's necessary to actually have semantically enriched documents that can go beyond XML and have like some sort of ontology representation of those standards. Now, something that you might not know are the technical components for the Smart Standards program. So first of all, it's the NISO SDS, the Standard Stack Suite. That's the XML format with which most of the standards from ISO, IEC, and some other STOs are going to be published in. It's a structural XML standard, basically, like EPUB or OXML. It just defines the structure of the documents, can then be rendered into PDF or HTML or whatever. It uses inside of it ISO TBX, so the term-based exchange, in order to represent the terminology. And under development are the smart information model, which goes beyond NISO SDS in order to have a much more finely granular XML document where it can actually identify individual requirements, individual sentences, and recommendations, etc. This smart addressing framework, which is basically the plural for standards developed by ISO in order to be able to address individual paragraphs, individual terminology in the standard itself, and actually link back to the standard. The NISO standard-specific ontology standard, which is life cycle ontology for standards, in order to show all the metadata related to the standard, the process in the publishing process in which it is right now, if it's being revised, and all of the other information related to the standard itself, but not what's in the standard. And Fonto XML, which is an XML editor in order to be able to create and edit these standards in the future. I didn't go into detail. I have backup slides if people ask questions afterwards, but there's a lot of material and I can't present everything in the short time we have. This new data-centric XML that we have for the standards, where we have all of the information in the standard in structured content, allows us to actually use these standards as an input to create ontologies. So the standards provide the input terminology for the ontologies, since it's all there in TBX format, the requirements for the ontology, because we've extracted requirements and recommendations, etc., from the standards themselves, and the data, the instance data for the knowledge base. And ontologies can provide machine actionable logic, references back to standards in order to see where that information comes from, why the modeling decisions were made, and actual structure for the knowledge base. So process by which you could develop ontology based on standards is starting with mapping the terminology that you have in the standards themselves onto classes and instances for the ontology, mapping the requirements, recommendations, etc., that we've extracted from the standards onto your decisions for modeling. So if you create process steps or whatever in the ontology, you can link it back to the requirements in the standard. Input that to the ontology development process, proceed to create a knowledge base. In the case, in our example case that I'm going to show afterwards, we used the materials engineering example. And then revise the standard, because whenever you develop an ontology and create a knowledge base based on information on these standards, you're going to notice a lot of inconsistencies that you have to report back to the standards committee in order to clarify information in those standards and revise it. So this is an example where we used the standard for tensile tests, the ISO 68921. You can see here going from the standard itself to the XML format of the standard. Then information extraction allowed us to find requirements, permissions, possibilities, and recommendations. We used this as an input to model our ontology. And then we're in communication with the German standards committee responsible for this standard to actually see if our ontology developed and it is was done according to the standard, and how to best include this ontology in the standard itself and how to revise the standard. So here's an image of the ontology itself. And you can see that each term in the ontology is actually comes from the standards themselves, and they have a link back to the XML version of the standard. So that would be my talk. It's just an input for discussion, and you can ask questions if you want.
Sorry, Alexandru, it was muted. So yeah, we have a question in the room from Johan. Go ahead.
Okay, thank you. Hello. Yes, Johan Trevor from DNV. Thank you for a very interesting presentation. I think in the Norwegian industrial ontology space, we have been very interested in digital standards for a while, and we have been eagerly awaiting the move from XML structuring of standard content into the sentence-based representation. I think you mentioned that on the roadmap for 2024. Now we explored a method for this ontology-based, sentence-level requirements representation for standards in a joint industry project called Hedi. So my first question is really, have you ever heard of this project? And the second one is, I hope you will be interested in talking about this offline, because I think we have some experience from working with this notion for a few years that we'd like to share with you.
Yes, Standards Norway is very active in this area, so I know of a lot of previous projects, but we should talk offline to see the exact details, and it might be some of the projects I know or some of the ones I don't know. I mean, we have a strong collaboration in this area of smart standards.
Sounds good. And let this also be an advertisement that everyone should engage in digitalization of standards.
Yes, I strongly endorse that.
Thank you. Anyway, I mean, we'll have the area to discuss in the panel later after the presentations. So I will invite the next speaker, Barry Smith. If you can stop sharing, please, Alexandru. You can start to introduce.
Okay, so as I think most of you, perhaps all of you know, BFO was, in some sense, which is complicated, approved as an ISO IEC standard. I'll give you a link in a few minutes. In 2021, and the background to that is quite interesting. So, as I will explain, and again, many of you will know this, BFO that came into existence in connection with the Human Genome Project. It was created by myself and a number of biologists who were already doing ontology at the turn of the millennium as a way of unifying the way in which data about genomes and then also data about diseases and other biomedical information were being captured in the registries which were being created all over the world. There was a real problem that the data was being collected differently in different countries. And the gene ontology was the beginning of standardization of all of that data. And as soon as you had the gene ontology, Then you also needed a disease ontology, an anatomy ontology, an ontology of proteins, and an ontology of small molecules like coffee and alcohol, which are useful ontologies to have. You needed a way of joining all of these ontologies together. And BFO was a top-level hub in the spokes, which were created around the gene ontology, including the ontologies of all of the things I just mentioned, and now many more. And the result was called the OBO Foundry, Open Biomedical Ontologies Foundry. And it was very successful, not just in creating a standard for annotating genes and genomes and diseases and so forth, but also in avoiding reinventing the wheel. Because every biologist and then every biomedical researcher knew that if they needed an ontology for biological phenomenon X, then probably the best place to go to find such an ontology would be the OBO Foundry. And so people didn't have a reason to reinvent the wheel. They could start from the starting point, which was already available. And if they wanted an ontology which was not in the OBO Foundry, then they had a strategy for building that ontology in a way which was consistent with the other ontologies in the OBO Foundry. Now, the US Army was impressed by this success because they had lots of data deriving from different sources, which were not necessarily communicating with each other in any direct way. And the Army needed a way of unifying this data, which was in some ways parallel to the problems faced with people using genomic data. And the US Army likes standards, because if you can say this particular artifact is an ISO standard to your general, then your general is much more likely to say, yes, we will use it. And so the US Army promoted BFO as an ISO standard. It was their idea. It was not our idea. The idea is that an ISO standard has to be promoted by a world-level trading organization, roughly. So an ordinary person in the street can't turn something into an ISO standard. There has to be a transnational reason, and this can be supplied by big organizations like the US Army. Now, so in 2021, BFO was approved alongside this standard, 21838. It says it costs you 224 Swiss francs. But if you read what's in the blue box here, you can see that if you press that button, it's free. So you can make your own decision. You can pay the money or you can get it for free. The reason it's free, and this is free also, this is free too. This is the actual BFO related standard, is because it's a standard which is used to create other standards. And ISO says that standards which are used to create other standards are free. All right, now there are two other standards which are in process. One of them is devoted to something called Dolce, which I think I've heard about. And the other one is devoted to a standard called Tupper, which is quite interesting because it's an attempt to create an ontology standard on the basis of multiple existing ISO standards, which sounds like a very good idea. The problem with Tupper is that no one knows about it. It's very complicated. It doesn't have any users. And that, in my book, is a problem. I think you should only standardize something when it's been used rigorously by many people for 20 years, roughly. So this is a picture of the OBO Foundry. It's a suite of ontologies which are designed to relate to each other. That's a very old slide. And there are today in the public domain, so I'm not now talking about ontologies which I can't tell you about because I can't tell you about them. But in the public domain, there are 447 ontologies which are reusing BFO. And most of them still are biology related. But there are today already 147 ontologies using BFO, which are not related to biology or medicine. This is in no small part because BFO is an ISO standard. So people think that if they're going to invest money in building an ontology, then they should use an ontology which is compatible with an ISO ontology standard. Now, being an ISO standard brings certain requirements, which you can think of as being the QWERTY keyboard requirement. Many people have learned to type using the QWERTY keyboard. I have no idea how they manage in Greece, but in the Western world, we all use the same QWERTY keyboard. If we try to change that keyboard, there will be panic. Now, BFO is like that. It's very hard to change BFO because BFO has many users. I want to change BFO, and it may take me 10 years to make even a small change. We've had very few changes over the years. But the problem is that the change has to be such that the users of BFO who already exist will approve it. A much more important problem is that not all of these ontologies which have arisen around the ISO standard are of equal value. Some of them are of less than equal value. Not everybody does this well. And so the question is, how can we maximize the degree to which people do this well? And we're doing lots of things on many fronts, including training, education, lobbying, evangelizing, harassing, humiliating, all the usual scientific tools in order to force people to think very carefully about how they implement BFO. And one, I think, very important tool in ensuring that ontologies are implemented coherently, systematically, consistently with other ontologies is by following the idea behind the OBO Foundry, which is the hub and spokes idea. And the hub and spokes idea doesn't just mean that you build the ontology on the basis of some central hub. It means that you build your ontology in tandem with the people building neighboring ontologies. So the creation of an ontology is always looking out of all 5 eyes in your head so that you see what all your neighbors are doing in order to avoid reinventing overlapping wheels. So this is the OBO Foundry. This is BFO. It's just the top level of the OBO Foundry. It defines it divides the world into those 3 kinds of entities. It's a little bit more complicated now. And these are some examples of ontology suites from about 3 years ago. And you can see that nearly all of the suites do have a top-level ontology. And you can see from this slide, actually, this slide is more or less correct from 3 years ago. 3 of them then already had BFO as their top level. And today, it's much more than that. So first of all, we have the Industrial Ontologies Foundry, which I'll be talking about tomorrow, and which Jim will be talking about in a minute. I only have another 193 slides, so don't worry. Then there is the digital construction ontologies, which are based in Finland. This seems to be, to me, a very interesting ontology foundry. And, so it's working. All right, so these are the modules of the DICON Foundry. This is this is a top-level DICON. You can see BFO up here in the lake-shaped thing, and then the rest is building information classes. And now, most importantly, we have several US government ontology projects now. One of them, a very big US government ontology project. The other one, somewhat big. So this is a collaboration between the Department of Defense and the intelligence community, which has been officially approved at CDO, CIO levels. It's also part of the new revised DoD AI approach that they are developing. And so this is an amazing step forward, because this means that a huge amount of resources are going to be invested in building ontologies around a coherently maintained, we hope, top level. And the mid-level from all of this is called the Common Core ontologies. And so this idea is that the Common Core ontologies are ontologies of things like artifacts, information, qualities, and so forth. And then there are many, many extension ontologies, including ontologies about space travel, I mean, satellites and so forth, orbits. So I think there are 800 domain ontologies which have been built to extend the top level ontologies in the Common Core, which in turn extends BFO. All right, so I would like to embrace the following principle, not principles, because we only need one. To have a good top level ontology, you have to have many successful, useful applications of it. In other words, many domain ontologies using it. If you have that, you have everything. And then a proposal. So I looked at the posters yesterday. I noticed that some of them, this is my final slide, some of them were devoted to additive manufacturing. But the authors of those posters seemed not to have spoken to each other. So if you want to do additive manufacturing ontology, and that's going to be a huge job because there are so many different dimensions, you need to talk to the other people who are trying to build ontologies of additive manufacturing and create a foundry. That's the only way you can ensure that you won't just be reinventing the wheel, which has been already invented by Hedi's team in France. All right, that's the end.
Thank you. Thank you, Barry. Perfect. If there is any quick question, or we can continue and then have questions in the panel. I don't know if online there is questions.
No?
Okay, perfect. So let's keep questions for the panel. So I'll invite Jim. It's in the continuity of Barry's talk on industrial ontologies foundry, which is a strongly, a unit of OAGI that Jim will present. Please go ahead.
Okay. And how do I advance this?
From here. You're saying from here.
Okay, great. Thanks.
Yeah, if
Hello.
you want to speak close to the microphone, they will hear you better.
Okay, sure. Okay. All right. Good morning, everyone. My name is Jim Wilson, and I'm the CEO of OAGI. And I want to thank Hedi for inviting me to join this panel. And he asked me to spend about 5 minutes and just give you an overview of OAGI. So given the topic, I thought it would be good to just tell you a little bit about me and my relevance to this conversation. So as I said, I'm OAGI CEO. I'm chair of the IOF Governance Board, and I'll go through the other members of that board here in a few slides. I'm the head of the U.S. delegation to ISO TC154, and that's the Technical Committee for Processes, Data Elements, and Documents in Commerce, Industry, and Administration. And by the way, the earlier presentation by Alexandru on smart standards, our technical committee is definitely right in the middle of doing some of that work. And even in my working group, we're starting some projects using the smart contract, the smart standard approach to things. I'm also the convener of ISO TC154 Working Group 7, which is digital business. And just last week, the ISO board chose me to be the convener of the newly formed ISO Smart Farming Coordinate Committee, which is a committee to kind of oversee the coordination of all the technical committees throughout ISO. And then I'm responsible for 3 standards or interoperability related open source projects. One is in agriculture around field operations data interoperability, and the other 2 I'll mention here in a moment. And finally, I just want to point out I'm a interoperability standards expert, but not necessarily an ontology expert. So all that stuff about, reconciling Dolce and MO and BFO just went right over my head. All right, so about OAGI. So we're a US-based nonprofit industry association founded in 1995 and funded by members. We do get a little funding through government sources on occasion. Our mission is to continuously improve interoperability through business process models, data standards, documentation tools, best practices, and training. And here are a few of our key resources. So we have something that we call ConnectSpec. We used to call it OAGIS, and that is a standard used by myriad global companies as an enterprise canonical model and a B2B model. Also, we have Connect Center, or as we also call it, SCORE, which is an OAGI tool used to manage ConnectSpec and used by members to create ConnectSpec-based JSON schema, XML schema, and API specs. NIST and OAGI have jointly developed that tool. And then finally, we have IOF ontologies, which I'll share on the next slide. 2 slides. So just kind of the highlights of the previous slide. Nonprofit standards organization, been around for 28 years. 2 big tools we offer. One is ConnectSpec, which is a standard, and then a tool called Connect Center to help manage that tool and then produce developer resources. All right, about IOF. So IOF stands for Industrial Ontologies Foundry, and it was established in 2014 and then moved to OAGI as an organizational unit a couple of years ago. Its mission is to create a set of core and open reference ontologies that spans the entire domain of digital manufacturing. The IOF will work with industry, government, academic, and standards organizations to advance data interoperability in their respective fields. So a couple of key resources there are the core ontology, which is a BFO-based ontology on which domain ontologies are based. And then we have the domain ontologies, which one ontology each specified for a domain, for example, supply chain and maintenance. And as I just said, they're based on the core ontology. So kind of the highlights there, IOF is an OAGI organizational unit. It's hard to believe, but it's been around almost 9 years, just a couple of years under OAG. And the 2 big deliverables there are core ontology and domain ontologies. So this is a list of our work areas. Some are more active than others. So we have a very active ontology development, architecture, processes and tools group. And they meet pretty much weekly and just define the process of creating ontologies, how to maintain them, publish them, go through release processes, things like that. Core ontology, as I mentioned, then supply chain ontology, maintenance, production service system, production planning and scheduling, MT Connect, systems engineering, material science, and zero defect manufacturing. So this is just a long list of members. To date, membership has been free, so not much of a barrier to people signing up. Our governance board consists of CERM, who's sleeping here near the front, Barry, who you just heard from, Demetris, and me, and then Rebecca Harista with Airbus. She's not here, and I don't know if this is a secret or not, but she is out on maternity leave, so I'm hoping congratulations are in order there. And then also we have Todd Schneider from Engineering Semantics, and then Chris Will, who retired some years ago from Dassault, was on the board, but he is traveling the world with his wife, so he occasionally shows up as a non-voting advisor. And I think my 5 minutes are up, and that's it. In the off chance you actually want this presentation, there's a little QR code there, and you can download it. So that's it.
Thank you, Jim. By the way, you can find IOF ontologies on industry portal. Okay, so last presentation will be on industrial data ontologies with Johan. And I don't know, maybe you will mention it that there is a big event in Paris ongoing now
Yes.
regarding this effort, and I don't know if it will be for voting or not.
This is for preparation of voting. So
Okay.
I actually brought with me the presentation that was given yesterday because I thought that would be appropriate for this forum.
Perfect.
So, sorry, how do I navigate? I have an
From
arrow
here,
key.
you can change the slides from
Okay,
here
good, thank you.
and just put
The last version you have. IDO.
yeah, then I think it was the last
Yeah.
one.
Okay. Perfect.
That's-
Does the presentation
You will
show?
change the
Yeah,
slides
sure.
from
Yeah.
here,
Yes.
but they will see them on the internet.
Yes.
Yeah. Just
Good. Yeah, thank you for adjusting to my great stature. I'm Johan Kluver. I work with DNV in Oslo, and I'm here to present the industrial data ontology, which is an ontology that that has been developed over a number of years. And just yesterday, at the so-called super meeting of the ISO Technical Committee 184, IDO was introduced as a new item proposal, which is the ISO term for that you use when you introduce a new standard. And in this case, we introduced both a new standard, which being the ontology, and proposed a series of thank you. A new standard series. So meaning that the industrial data ontology, the IDO, will be one part of a new series of ontology-based standards. So what is IDO? IDO was used to be a part of the ISO standard 15926. This has been around. This 15926 came about mainly in 2003 with the Part 2 data model, which was based on the ISO mandated language Express, an object-oriented modeling language, for short. Now we adopted this for use in industrial projects, mainly in the Norwegian oil and gas offshore industry, and had projects during the last 10 years that have been very successful, meaning they have been industrially and economically, commercially successful. So the adoption of the 15926 data model as an ontology has been demonstrated to be of use and of interest for industry. I'd like to emphasize that the adoption from an object-oriented Express model ratified by ISO in 2003, at the same time that RDF came out, that the first version of OWL came out. This required a variety of changes, and as we adopted for being OWL 2 native to the extent possible, as far as possible, have been trying for IDO to be OWL native, and this was facilitated to a great extent by adopting concepts that were much better expressed in the basic form ontology, upper ontology. So what IDO is today is a sort of the result of throwing ISO 15926 and the BFO, and also obviously other ontologies like Dolce have been inspiring to our work. Just squeezing the best parts out of that and ending up with a language that allows for precise modeling and which really takes care of preserving the capability for automated reasoning. Automated reasoning, I think, is more natural with IDO than with the alternatives. So that's been a very strong ambition for us. So as I mentioned, IDO is not really new. It was initiated in 2008, and it has had a very significant consistency since we introduced it back in the integrated operations in the High North Joint Industry Project in 2008. We found that due to irreconcilable differences, which I think is another term for divorce, we divorced 1596 because we could not accept the requirement to stay within a four-dimensionalist paradigm. We could not accept other certain disadvantages with which the 1596 community would not give up. The current offering consists in a document and an ontology, an OWL2 ontology, and the document will be the traditional ISO standard document. The main contents of this document is that we have a complete textual rendering of IDO. This actually means our document as an ISO standard document is slightly different from what you will find with the 21838 Part 2 BFO ISO document, where the ontology itself is not being documented per class and relation and so forth. Rather, with IDO, we have one document where you can look up all of the terms and read the definition, look at examples, hopefully worked examples, where we have put a great deal of effort into ensuring that diagrams are provided where they help communicate how the ontology is intended to be used. And we have a certain setup which allows us to preserve a high degree of consistency between the documentation and the ontology that is provided and intended to be used for implementation. Should IDO aim for satisfying the requirements laid out in ISO 21838 Part 1? Well, we have considered this very carefully. It has not been decided yet whether it will be done within the coming period of 3 years where the IDO will be made into a standard. But I think it's very much something that we would like to discuss, and input from the community here will be of great interest to us. And I'd like to raise a question for everyone to consider, does satisfying the 21838 Part 1 requirements on documentation and documenting conformance to the requirements of Part 1 there, do they help OntoCommons in developing a top reference ontology? Do they help a project like OntoCommons promoting interoperability between upper-level ontologies? I think the answer ought to be yes, and if it's not, then that might be something that's worth looking into. So IDO is also set up to work well with ontologies that have been developed outside of the IDO umbrella. I think the semantic sensor network ontology is a good example of that. That has actually been, in recent years, freed from its tie-in with Dolce as upper ontology. And now we come here with IDO and we will provide, a thin mapping that allows you to use it with IDO. And the same could obviously be done with other ontologies. GeoSparkle, the time ontology, these are also examples of ontologies that are actually not bound to a particular top-level ontology, but which will be usable with IDO. And I'm mentioning all this in order to say, IDO, here we have a very clearly, explicitly OWL2 centric, industry-focused ontology. It is different from Dolce, it's different from BFO, but it should be usable with many of the domain ontologies, many of the specialized ontologies that are developed without other top-level ontologies or without top-level ontologies. Interoperability is really a core aim that we have. In addition to reuse of existing ontologies, so we will certainly have extensive work on developing industry-specific ontologies, in particular for the energy domain, meaning oil and gas, wind power, electrical distribution, and so forth. The IDO document also contains detailed use cases where we will go to at length into maybe 12 pages, 15 pages of really tackling hard modeling problems. So far, we have only one in this draft proposal. It's called Pump with Firmware, and we go into the details of how you can model both a mechanical system and the software, where in a case where it matters how many bits you have in each register of your sensors, meaning that you model your equipment in a way that allows you a great deal of control over the precision, the reliability of the output. I think we are introducing IDO as a new standard in the ISO space because there are large international companies that already use this standard, and they wish to ensure that their efforts have a reliable basis, something that they can rely on for years, and they also obviously want to collaborate on developments. So I think I will just show this to end. The plan is for a 3-year project and to publish an international standard in the fall of 2025. Thank you.
Thank you. Perfect. So I will invite our speakers to be in the panel, and we'll start the questions session. Yes.
Yeah, there's one who was in.
Is there?
Yeah. All right. So perfect. I would like to thank you again for your presentations. And I have in mind, I'd like to rely on what you presented. Let's say that we see the two approaches, is that we have ontology, like BAFU, and we go to the standardization process. And then we have standards, as Alexandru did. They start from the standards and they develop ontologies. So, and the third one is like, okay, there is standards, there is standard ontology, and they are building standard ontology. So there is the different approaches. And I don't know if we have to keep 3 of them, or we follow what Barry said, is that we need to test before. The ontology is used by a huge community, and then we go to the standardization process. Why I say that is in a perspective of adoption and use, because I think also something that came on the table usually is the quality of the ontology. Is it good quality or not? It's the same, I think, for standards. It's a good or bad standard. So is it this period of test and use in the community is necessary to go through standardization of ontologies? So I would like to hear about, from you, your thought on this topic.
Yeah, I'll go first. So yeah, I have an opinion on this. It's interesting. So in OEG, we're really proud of the work we've done over the last 28 years on ConnectSpec and how companies have implemented it as an enterprise canonical. Now, as an enterprise canonical, the purpose is to map to it and map from it. It's about moving data around. The semantics are all about how the standard is described. It may or may not match reality one for one very well, but it works great in moving data around and making sure people know what it means when it gets there. Ontologies are something different. And what I've observed over the last few years is that as ontologies have kind of, I guess, gained a resurgence, so it seems to me, that there are many so-called standards organizations that they just, find some sort of push button approach to express their XML schema as RDF OW, or RDF or OW, or something like that, and then they declare that they have an ontology. And that strikes me as something very dangerous. And so my opinion is ontologists should do ontologies, other standards should do standards, everybody should do them really well, document them exceptionally well, and then find effective ways to meet in the middle. That's my opinion.
Thank you. Yes, buddy.
So I already said yesterday that wouldn't work because the way in which standards organizations work when they write definitions does not pay attention to logic. And in order to create a coherent body of ontologies based on standards, a new regimen for writing definitions has to be established. And the official ISO creed, according to which when you define a term, you should take account of the way the term was used and defined in previous standards, has to be adhered to. Because at the moment, no one cares. You create a new ISO standard. Some words have been defined 20 times in different ways in different ISO standards, which is against the ISO rule. But so long as you have that state of affairs, then there's no point creating ontologies on the basis of ISO standards. However, I would add something to what I said earlier about TOPA. So TOPA is created by a group around Michael Gruninger in Toronto, who is more of a mathematician than he is an ontologist or a logician. I take that back. He's a very good mathematician and he's other things as well. TOPA is an ontology based on existing ontologically well-developed ISO standards. So there are some. One of them is GeoSparkle. GeoSparkle is an ontologically coherent ISO standard, which is then part of the TOPA, which means top upper. And so I think that TOPA is doing what you suggest already, but it works only in those rare instances, which tend to be the ones where mathematical standards apply, where we have standards with good definition, ontological.
Thank you. Johan, what do you think?
Well, I was going to say, I don't, Barry, I don't think that I expressed my opinion clearly. So there's nothing you said that I disagree with there. Yeah, but my point about meeting in the middle was you have standards. I'm not talking standard ontologies. I'm talking just e-business standards, domain standard, chemi standards for the chemical industry supply chain. They've been around forever. EDI standards, ANSI X12, EDI or UN Edifact. And there's just trillions of documents flying around all the time. And then we have ontology development. And it seems to me that people want to leverage ontologies, but still the data has got to somehow be connected somewhere, somehow. And that's my opinion. They shouldn't try to make an ontology out of, for example, UN Edifact. I think that would be a disaster, waste of time.
Mm-hmm. Perfect.
Yeah, so I would like to that's exactly the reason why I showed the first presentation. So in material science, material characterization, many of the methods are defined in the standard. So basically, we need to describe those characterization methods and outputs that the standards define. So that's why we started with the standard to build the ontologies. We built ontologies with multiple experts based on those methods. And since we already built those ontologies that are more or less according to the standard, we can link it back. So that's the process that we're suggesting, because we took our terminology, we took our requirements from those standards in order to link them back. That's what smart standards allow us to do. It won't work in all of the domains, but it works in many. It also provides a starting point for many people, because when you choose your terminology, if you can already, like search somewhere, okay, is there a standard that already defines this terminology or something like that? Can I just take it and start my ontology on it? Yeah, I mean, it's not like the mathematical logic requirements. Of course, it's not very well defined. There are overlapping standards. Some things are defined in multiple parts, but this is also part of the process. So actually having the standards in an XML format allows you to find these inconsistencies, and it allows you to improve these standards. So it should be a process that comes from both parts. One, from the standards organizations that need to publish their data in a searchable data format, more or less like a database, and from the ontologies and ontology developers that actually find those inconsistencies and give back to the committees tips on how to do it better, how to formulate those things better. It's not like they don't want that. If you tell them, I mean, they're going to discuss it and many times find ways to revise those standards and make them consistent. That was my input.
Yes, thank you, Alexandru. Sorry, I was muted. Okay, please go ahead, Johan.
Yeah, I'm very happy to be unmuted. I'd like to offer a complementary perspective. By the way, my good friend Anders Gjerder from the company Able is here. He will be speaking later today, and hopefully he'll be touching upon some of the issues that I have in the back of my mind as I'm going to say this next thing. Barry, you emphasize the point that things in ISO standards or other industrial space standards are repeatedly redefined, and obviously the quality of the definitions that we find there is generally not so great. Well, if you were to say, let's now start using ontologies to carry on this activity, that's not necessarily going to bring any improvement at all. I would like to suggest that we consider a very different perspective. Look at what industry is doing today. It is governed by rules and regulations that are laid out in standards at a large scale, where whatever you touch that is a product of industry, which is, let's face it, probably very much of what you touch at all, it's going to be a product or a result of processes that have been regulated and constrained by hundreds and hundreds of industrial standards. And these products actually exist. It's not like by miracle they assemble. No, they were made by people who, to a large extent, actually followed the rules that are expressed in the standards and then, required by law and all of this. So there is a vast space of industrial need for following rules and regulations in a way that is according to intention, as laid out in the standards, that is according to good engineering practice, and that is as consistent as you can hope to be, in order that you don't like sell poisonous food or offer people to ride bikes with where the brakes fall off, right? Ontology has a huge mission in this space. We're providing a stable top-level ontology from which you can specialize into domains and ensure that you have as much consistency in the definition of your domain special terms as possible. Also, hopefully, providing semantic restrictions to avoid inconsistencies. You know, we should definitely build all this using OWL for its ability to exploit description logic reasoning, which is the only player in town for reasoning. At least that has to be the starting point. The hub and spokes model, or what other people tend to refer to as modular ontologies, I think this is just the same concept. You know, you have your top level ontology, and from that you build gradually into more specialized domain modules, which you will sometimes want to combine in new ways. Rarely will you want to use hundreds of ontologies at the same time, but sometimes you might need to in order to ensure that you identify inconsistencies, which are not trivial. So I believe industry standards, when represented not completely because that's like a non-starter. Any industry standard has a narrative that you cannot ontologize away, but the rules and regulations, the constraints that are laid out in industrial ontologies can, to a very great extent, and we have shown this in practice in industrial experience, they can be expressed, they can be captured in modular or hub and spokes ontologies. IDO happens to be in a slightly different space than BFO, but of course there are many points of contact between different industries. Applying this approach, industry standards can be improved. The usage of industry standards as they currently exist in PDF, XML formats, and so forth can be vastly improved, and ontology development can, in turn, vastly benefit from this commercially interesting, highly valuable application into the existing industries. So my observation is, we do have industry. When I buy a bike, the brakes don't fall off. That's very much thanks to the standards. And ontology can make the application of standards in industry so much better for us at a very, very broad level.
But here I have to raise something. I usually say this. Usually, when we talk with people, we say, yeah, you have interoperability problems, so ontology is a valuable solution for that. But ontologies are not interoperable. I mean, that's amazing to see what you are doing. And if I take the example of IUF, so there is IUF core, and you are developing ADO. I think that there is some overlapping. Okay, how to ensure that there is interoperability there? And also in some domains regarding the hub and spoke approach. So when you talk about industry, is huge. When you talk about industry and materials, is more huge. So what is the best way to have agreement at a certain level to run with this interoperability of ontologies? Okay, maybe alignment is not a good idea, as Barry said, on top level. Is it a good idea in mid-level and domain level?
For example?
Yes.
One example, Johan. So I have the impression that IDO is a kind of middle-level ontology.
It's more appropriate to call it the top level ontology.
Okay. Have you checked the recently released RF core ontology?
Yes, to some extent. For the group of companies that I've been working with, the IOF core does not currently quite fit the bill. But I can assure you that there is a ton of goodwill among these companies towards the activities of the IOF in developing the IOF core. I'm just thinking, the harmonization, the convergence on the best solutions that we all want is not done overnight. IDO has benefited massively from learning from what BFO has done, as a top-level ontology. We hope that some of the solutions that we have found, but we cannot communicate all that we do while doing it, right? So we hope that some insights will be useful for BFO flowing back, and then over time we should see convergence on best solutions. That's my maybe naive hope. I do rarely see. I mean, this is, I guess, an aspect where the ontology community differs a little bit from the wider software or information technology space. We're not trying to kill each other. They are.
We have the disposition to do. Yeah, so I mean, also that's I know that people from IUF that are involved in this. I mean, ID work, and which bridges can we have to align to work together more to have this bridges of interoperability? I think it would be a good idea, and also in terms of development. In terms of development, we can see that there is different approaches to develop ontology. Do you think that having a standard methodology can help to reach interoperability between ontology and standardize, to support standardization efforts? Yes?
I have one very concrete proposal for this. Within the IDO community, meaning largely a Norwegian dominated community, but with of course friends in many countries, we have taken the concept that you should generate an ontology from a data set. We've taken that one step further than what it looked like 10 years ago. Essentially using data sets that are completely devoid of any ontology content and applying expansion rules to them. So if you wish, and I'm thinking now in a very in industrial, I have an industrial mindset. So say that you're talking about colors. We have quite beautiful colors in this room: red, brown, gray, black, and so forth. Let's say that you want to make an ontology that provides you a vocabulary of color. So you have a table of several different color names. You probably have some data on the wavelengths and so forth. A table of data about colors can definitely be expanded into ontology classes and relationships, whether you use BFO or Dolce or any top-level ontology. There's no interesting discussion to be had here. Clearly, any ontology worth its salt is going to be able to somehow provide with a pattern for representing color. And if you have an agreed upon source, which was made completely without even thinking about ontology, about color, then you can use that. This is very, very powerful because the identifiers in a linked data semantic web conception, the identifiers for colors could definitely be managed, independently of top-level ontology. As soon as you want to have some intelligence in your system, then you cannot do without the top-level ontology. But obviously, interoperability is also about agreeing on vocabulary, and very much of that vocabulary is not really all that sensitive to which top-level ontology you're working with.
So let me just take your color example and go back to the early phases of genome research. You had lots of data about genomes, which was developed, collected by scientists It's all very accurate. But scientists in Germany did it differently from scientists in America. But and thereby they were losing value because the same gene would be discovered in Germany and in America under two different names, and they wouldn't know that it was the same gene. How did they solve that problem? The answer is a big man. There was a member of the genomics community who was respected by everyone, and he said, we're all going to use this ontology. And everyone said, yes. You need a big man, or you need a force, you need a charismatic individual who is respected in the community to tell people to use this terminology rather than that one.
Yeah, but I mean,
You're the big man.
I think this is very interesting, but it's not exactly the same as what I was trying to lay out. I mean, a table of colors, wavelengths, that's what matters, and people agree on what they are, irrespective of ontology. I think for this gene ontology case, it's probably not as clear cut. You need someone to say we will use this terminology to talk about genes, and then you're sort of back to you couldn't find a much simpler representation of that ground set of data that people need to agree on than something that was expressed with the level of complexity of gene ontology. I'm not saying that every piece of every domain of investigation is simple enough that we can have it in a 7-column page.
Okay, I think that there is still the possibility, even with relatively simple data, of having conflicting ways of approaching it, which would spoil the ontological solutions that you are in favor of.
Yes,
and that we still need a solution to that problem.
I agree.
So I know cases where it's been solved by means of a single individual who is very charismatic and very influential, and I do respect him. If we have that, we can do a lot.
Well, I think it's different perhaps in the bio domain. There is no software vendor, perhaps, to find each other. And in this case, I think there are a bunch of software vendors who want to use different things. Even in the automotive industry, even as big as GM, cannot tell everyone to use a single standard. Walmart can tell only people who want to work with Walmart to use the standard that Walmart want to use, because if you want to work with Walmart, you have to use my standard. So it has to be.
Yeah, I mean, this authority, I think it depends to the position is like, okay, if you take the aerospace domain, if Airbus and Boeing, they agree on something, so it will be done. It's like authority for all their suppliers in the domain and so on. So such kind of authority, I mean, I think it's case by case. But also I would like to highlight something regarding the example, because also this discussion is interesting when developing ontologies. And I will back to a question that I asked you, Barry, 2 years ago regarding the granularity. When we talk about colors, for example, let's take this example. Is colors or individuals? Are there instances or classes? So this is a big question that I have with my students, when discussing with people. So what is the level of the granularity? Where we should stop? And just to remind you, your answer was, when I asked where I should stop, you said when your funding is end.
And you don't think that's a good answer?
Let's say we still have funding in OntoCommons till end of October.
So the question about instances and classes is not, I believe, a question about where we should end. I do not believe that there are leaf nodes. In other words, every node in an ontology can, in principle, be further divided. And if you believe that there are leaf nodes, you'll make mistakes. You will basically take away any possibility that your ontology will have a long life, because somebody will come along and say, we need to have blah, blah, blah. So there are no leaf nodes. Now, when you're dealing with colors, that everything can be reviewed, can be seen as a class, but then every class will have to have instances, which will be color samples, which you can show people. And if you reach the point where you don't have samples which show the difference between colors very deep in the ontology, then you're going too far. Even if there is a wavelength difference, if you can't see that difference, if an expert on paint and light and so on can't see that difference, then probably you're going too far. But every case would be different. It could be that even if you can't see the difference, it's still important chemically or for some other reason. So you may need a chemical granularity sensitive color ontology for some kind of purpose.
Yeah. So why I'm talking about this because I back to the methodology. So when we discuss with industrials those questions back, okay, how to do it, when we stop, what is the coverage? So there is a lot of questions on this topic. And as you said yesterday regarding training, to train people according to which methodology. So this is also, that's why we think that it's important to have a standard methodology to do it. So what do you think about this?
So this is the elephant in the room. So at the moment we have BFO standards and then we have Dolce standards, and they are overwhelmingly dominant. So there are, EMO is not yet dominant. It may be 10 years, 5 years. But at the moment there are only 2 games in town. Now, BFO, I think, has more interest from users of ontologies. Dolce has interest in people who are interested in logic. Claudio talk this morning, it was a talk for logicians. It was a fantastic talk, but it was not going to be about help to industrialists. I think BFO, from the very beginning, has worked very closely with users of ontologies, and we stick with users for years and years. It's true that we have too many users now. We can't stick with all of them. Or we've tried, but we don't have the resources. But we can stick with the main foundry users. And the problem is Dolce has not emphasized support for users. It's emphasized logic and related matters.
Stefano is there. So we will continue to discuss on the lunch time. So we are running out of time. I'm sorry for this delay, but I think the discussion is amazing, and let's continue to do it during the lunchtime. So the next session will be delayed or not? I don't know.
No,
You will announce.
yeah.
Okay. You'll announce also for hands-on sous le sens.
Sorry?
Sous le sens. You have
You
it.
have the agenda here if you want to announce anything.
Okay, just to tell that in the afternoon that there is parallel sessions,
Yes.
and there is hands-on sous le sens also. So we'll have also the links on Hermit, and so there. What we have the afternoon is session on priorities on top level and mid-level ontologies, and in semantic interoperability and fair semantics. So there is 2 parallel sessions, so in different rooms, and there is another session I think at 3 on sous le sens tool hands-on. So we'll announce later regarding the rooms, I think. So thank you at 3. Yes, sous le sens at 3. So thank you very much, all of you, and have fun during the lunch. And for people online, see you later.
Just a couple of announcements from
Yes,
myself.
go
Thank you all. Don't worry about the timing because there's still half an hour to have lunch, 35 minutes. So we meet here in 35 minutes.